Hey, hi, my name is Tattu. Today, I'm gonna present you the cybersecurity project which was done by me. It is triple level data security using cryptography and steganography techniques. Let's get started. So this is gonna be the agenda for this video. We'll be going through the introduction of the project and explaining the existing versus the proposed method for this project and architecture and algorithm that I used, and finally the results. Yeah, moving on to introduction. So nowadays, like there is rapid development in the technology, which had great influence on the exchange of information, especially. Uh, but while exchanging this information, maintaining security will be the essential and key concern for a lot of us, right? So there may be a lot of information that is being transferred across remote locations on the internet that may consist of sensitive personal data. So there is high probability that the sensitive data may be intercepted, just like the man in the middle attack or whatever. Um, we need to find a way. So somehow we need to secure this thing so that almost all the users need private and secure communications for a lot of reasons, maybe confidentiality or whatever. So that's we consider secure communication is of utmost importance, right? So we should not be uh, allow the unauthorized users to access the information without the access. Yeah. And coming to the problem statement, uh, to do this, like to have the secure communication to provide security for such information exchange, we have techniques called steganography and cryptography. Let me talk about cryptography. So in this technique, the original message will be transferred into some non-readable message, like if you consider the plain text, performing some mathematical operations or whatever, an algorithm which gives us the ciphertext which cannot be readable, or it doesn't make any sense even if we able to read that. And whereas steganography, in this we will hide the information in the digital media as such. We have four types of steganography, like text, audio, video, and image. So we can hide information in four formats. However, both the techniques have their own drawbacks. So, which means, like, if you take the example of cryptography, if the key is obtained by the attacker, so he can easily able to decrypt whatever the message that is being passed. And whereas steganography, it is like, when if the existence of information is found, like what if the attacker found out that there is some information, so it is obvious that he can easily able to access that without, as it is not encrypted, it just hidden in the whatever media file is there. So both of them have their own drawbacks. So yeah, as I just explained the background work, the cryptography encryption decryption process was shown in the diagram. So where a plain text was fed to the whatever encryption algorithm we choose, which gives us the ciphertext, and the same thing like the receiver side. It's the reverse process kind of. The decryption algorithm was applied to get the original message. And yeah, for steganographic, the sender size carrier image, so whatever message we are going to pass, that was put in a carrier image and applied steganography on that, which gives the stego image. So the image resulting will be almost similar. I mean, you don't see any difference in the image with data or without data. So as the receiver side, it is again the reverse process, just like the cryptography. And then yeah, existing system. So these techniques are a lot widely used by many of them, like to achieve secure transmission of data or whatever. But both of them are prone to, like, eavesdropping or man in the middle attack. So as just now I told, if there is key to is the if the key is known to the attacker, so they can easily decrypt the message. And if the steganography thing, it doesn't have any encryption, it's just hidden, so if the attacker finds out that suspects that there is an information in the image, so it can be easily cracked. So using them independently might result in these kind of things where the confidentiality of the information is lost. But here, coming to the proposed system, this proposed system will combine both the techniques to provide the greater security, right? So it combines the steganography and cryptography techniques. It aims to provide the triple level data security. So triple level, I mean, so using cryptography, there is two levels. Like we are going to use two levels of cryptography, and then a steganography is going to be applied on the whatever ciphertext we get from the cryptography. So which will enhance the security. The techniques will make use of symmetric key encryption, so the sender and receiver can have the common shared key. Advantages. So utilizing two levels of cryptography improves the security, because like even if consider the attacker knows the key, but still they can't able to decrypt the original message because that was hidden in the image. Like even if they know key for one object, it might be hidden using the steganography, so the information or data whatever we're trying to send, that will be very secure, and it will be very difficult to track the second key even if we found the first key. This is the pretty brief architecture of how the implementation is. So if you see in the diagram, the input message will be fed to the blowfish algorithm, which will generate a ciphertext, and the same ciphertext was given as input to the AES algorithm, which will gives us back the second ciphertext. And now after two levels of cryptography, now we are going to use steganography. That is where in the LSB encoding. So LSB encoding technique is one of the technique in steganography. So now this ciphertext 2 was fed as an input to this LSB encoding, which will gives us the stego image. So this is the final ciphertext we are considering with three levels of security. So coming to the decryption process, it is the same thing. Like first the LSB encoding done on a stego image, and then it is fed to AES for decryption, and then the blowfish algorithm, which gives us back the original message. This is how this is a flowchart of blowfish algorithm. This figure shows. So it is faster, and it has good encryption rate. So that's why we have chosen blowfish algorithm for cryptography. So it holds the 64 bits block size and the key size will be, it has a variable key size 32 to 448 bits, and in this there will be 18 subkeys and total of 16 rounds. So the same subkeys are needed. I mean, the same subkeys are used in the encryption and the decryption process, and these are stored in the P array. So if you can say P0 to P15. So these subkeys are stored in P arrays. So there will be a total of 4 substitution boxes for the blowfish algorithm, and each subkey is XORed with the input key. And after the 16 rounds, so I told that there will be 16 rounds. After these 16 rounds, there will be pre-processing step, as you can see in the figure. So in this pre-processing step, the first 32 bits will be XORed with P1, and the last 32 bits will be XORed with P0. So whatever the resulting what we get from the 64-bit text, that is considered as the ciphertext from the blowfish algorithm, and then this ciphertext will be fed as input for the AES algorithm. So as you know, AES has almost similar 4 steps, like the sub bytes and the shift rows, mixed column. So each there will be round keys in the each steps, and for each round perform all these steps. and whatever the ciphertext we received as output of blowfish algorithm, that will be now input for the AS algorithm. And after this, uh, we will be ending up with having ciphertext 2 after AES is applied. And now we are done with two levels of security with the help of cryptography. Now let's add a third level with steganography. So we will be using LSB encoding for steganography. So the reason why I chose is the most well-known technique in steganography, and it's a lot simpler approach when compared with other. So what it does is it simply embeds the data into the cover image. It works by replacing into it works by replacing the information in a given pixel with information from the data. So also the LSB encoding technique suggests that the data can be hidden in the least significant bits of the cover image, and this will helps us, the human eye wouldn't be able to notice the information that was hidden in the image. So you can see the process that was listed. uh, Initially we convert the message that we are going to embed it into binary, and so we'll be reading the cover message. So then it converts the cover image from decimal to binary 16, and then break the byte to hidden into bits. So and then it takes the first 8 bit of the data from cover image and replace the LSB, that is least significant bit, one by one of the data to be hidden. So that results in the image which has the information hidden in it. And the solution whatever I propose works with different image formats as well, like JPG, PNG, or whatever. And it is also saying that after all these techniques was applied, the image doesn't show any sort of distortion with, like, if you consider the image previously without being information hidden in it, and after LSB encoding, there isn't much difference between both the images. Yeah. And yeah, coming to the results, so the graphs here shows the encryption and decryption types times that have taken for all the algorithms, the AES, triple DES, and DES, Blowfish, and RC2. So if you look at from the graph and consider lowest time for encryption and decryption, the Blowfish has the very good throughput in case of encryption and decryption time, and after that here comes the AES. So that's the reason I chose these two algorithms for cryptography. And also I want to discuss some advantages of this Blowfish. So it is very fast when compared to any other cryptographic algorithms. The encryption rate was fast, and it is very compact, like it can execute in less than 5 KB memory as well. And it's also very simple, like because of its primitive operations. It uses like addition, XOR operations, etc. And it's also secure, we can say, because of its variable length key up to 448 bits. And yeah, so now this graph shows the comparison of two level with three level based on encryption time. So only using Blowfish and LSB encoding doesn't show much throughput. So but whenever I include one more level of security with the help of AES, so totally of three level to cryptography and one steganography. So that graph is depicts that the security throughput was much better when using the three of them. And yeah, thank you. That's it.